So once we've kind of refreshed a little bit about what pressure is and how we can calculate pressure based on different factors, we know we have volume, temperature, and number of particles that all affect the pressure, we can also talk about something called partial pressure, which is actually way easier than any of the other calculations. Partial pressure is simply the idea that the total pressure in a container equals the sum of the pressures of the individual gases. So imagine that you have a container of mixed kinds of gases. Say you have a mixture of water vapor and oxygen, or water vapor and CO2, carbon dioxide, or hydrogen and oxygen gases. Any different combination of gases. It can be 2, it can be 5 in one container. The total pressure is simply equal to the sum of the individual pressures. So pressure of gas A plus the pressure of gas B plus the pressure of gas C, etc., etc. So A and B in this simple formula would be the different gases, whether it's carbon dioxide, water, oxygen, whatever the gas may be. So let's look at 2 different examples. Our first example says, suppose you combine hydrogen gas at 2 atmospheres and oxygen gas at 0.7 atmospheres. Calculate the total pressure. So remember, pressure total, so P total, equals the pressure of the hydrogen plus the pressure of the oxygen. So pressure total is simply 2 atmospheres, because that's our pressure of our hydrogen, plus 0.7 atmospheres, that's the pressure of our oxygen, so our total pressure is equal to 2.7 atmospheres. See? Easy. It's important to note that the masses of the particles, so we know that oxygen is more massive than hydrogen, does not affect the pressure. That was never one of the factors involved in calculating pressure, just volume, temperature, and number of particles. So if we already know the pressure of each of them individually, we combine them together, the total pressure is just the sum of those 2. Let's look at one more type of problem you might see. So the total pressure in a container is 721 millimeters of mercury. So say that's something you calculate. If the container holds water vapor, and the water vapor has a pressure of 19 millimeters of mercury, and oxygen, what is the pressure of the oxygen? So say you collected something over water, you have water vapor, and you know the pressure of the water vapor, 19 millimeters of mercury. But what you're interested in is the pressure of the oxygen. You have to factor out or take out the pressure of the water vapor, because that's skewing your answer a little bit. So again, pretty simple. Pressure total is equal to our pressure of our water vapor plus the pressure of our oxygen. We already know our total pressure, that's 721 millimeters of mercury. And that's equal to the pressure of the water, so that's 19 millimeters of mercury, plus whatever the pressure of the oxygen gas is. So if we subtract, pressure of our oxygen is equal to 702 millimeters of mercury. Just simple algebra. And that's all partial pressure is.